Hey guys, nothing in this video is required, but if you're like me and can't get enough, here you go. So to start off with, I'm going to show you the difference in the power valves. So the one on the left was made from 99 to 01. You can see the obvious difference is in the valve stem itself, where it's just got the big full aluminum valve stem. This system worked great, but the only thing that opened it and held it closed was those torsion springs, so you would get some flutter, and then that flutter would make some chatter and wear, and it wasn't that great for performance either in the low end. In '02, they introduced a holder to hold this shut so it wouldn't flutter, and they just carved out the back side of the aluminum there, and the holder pinched against that and held it shut. Then in '03, right up through current, which now 22, they have where they machine down that big aluminum tip, leaving a little stud, and then they press this steel cap over the aluminum, so it would give them a steel surface for that holder to bear on, holding that valve closed. That stopped the flutter and helped them with some low-end performance. One situation that developed, you see a lot of places where this little aluminum stud in there broke, and then the steel cap would pop off, and it would float around and jam up the PV works, and then the holder was useless at that point, so you were back to the fluttering early style. The good thing about this kit is that it doesn't matter what vintage of valve you've got. It can be the old style, it can be the new style, it can even be the new style with the broken cap, because it only relies on that pin now. So the pin that's pressed through there, as long as that's good, then the valve is usable and serviceable with this new kit. The other thing that's important on all these valves is the stops. Okay, so on each side of the valve, you see these little crescent moons sticking out. Those are what bottom out in the cylinder and cause the valve to stop moving and going too far and making contact with the piston. And sometimes you'll see where this little ear will break off, one of them. I don't know as I've seen one where they both have broken off, but the stops are really the most important thing. Again, the valve stem doesn't really matter which style it is. It's all going to work with this kit. The other thing I'll point out with these valves is they need to be compatible with the cylinder you're running. So in '03, when they redesigned and came out with the final version of the valve, '03, they also redesigned the cylinder a little bit, or machined it a little different, to accept the newer valve. The biggest difference is in the tips of the blades. I don't know if you can see here, but they are squared off. They don't come to a point like the old valves came to a point. So they were like a sharp, pointy point. So if you've got the 5-up, the newer cylinder with an older style valve, just test fit it in the cylinder and file that tip on each tip. Just square it off, test fit it, and you'll see you want that to have a little clearance when it's closed against the stops. When it's closed against the stops, you should be even able to rock the valve slightly back and forth, knowing that it's bottoming out on the stops and not on the tips. So make sure that's the case. If you're mix matching years, file that tip a little bit so it bottoms against the stops, and you can run them in the newer cylinders. Another thing I want to bring up is modifications of the cylinders. Now, some people have the base of their cylinder cut, so they take material off of here, essentially lowering the cylinder, and that accomplishes several things that some people like. We don't advocate it, but you want to understand if you've got a cylinder that's been cut, or if you're one that has been, plays around with base gasket thicknesses to any substantial degree, then you're going to need to listen here for this part. So how do you tell if your cylinder has been cut or not? Well, other than measurements, and it's not easy stuff to measure, and castings vary from casting to casting, but the one thing I will point out, and I hope you can see, and if you can't, I'll try to put a static picture, but if you see this little stepped ridge, okay, from the factory, I'll show you, they are just a nice radius where the cylinder deck transitions into the cylinder wall. So that nice radius, they cut across into it, or cut down and then out, and you'll see evidence of that right on here. So it'll look something like this. Try to get it for you. That's one giveaway. I'll show you the stock cylinder uncut. That's got a nice smooth radius right in here. Nice smooth radius. So when they cut down in, they cut into that radius typically. So it leaves you that little stepped groove. That's one indicator. The other way is on the stock cylinder here. As they cut their way out, it cuts into here where the reed cage goes on a little bit. When the cylinder has been cut, that also gets cut down. And you'll see, like here, it's almost, you can start to see that thread even from the reed cage screw that goes in there and holds it. And this surface is bigger. So if that's cut right down to a point, or a cutting edge there where that thread is, or even see part of the thread started, that's a good indication that it was cut. But the main thing you see, again, is that ridge right there. If you're going to run a cut cylinder or little to no base gasket, you need to set up the configuration of the governor a little bit different. And the only difference takes place on the weight side of the linkage collar, where the linkage goes in. And there we're just going to shorten that up. So you've got the weights, then you've got the weight collar, and then a 0.8 millimeter thrust washer, then the thrust bearing, and then a 1.1 millimeter thrust washer before the linkage collar. With the cut cylinder, you're going to run a 0.8 millimeter washer against the weight collar, then the thrust bearing, then a 0.8 millimeter thrust washer before the linkage collar. So you're going to be taking away 0.3 of a millimeter from that weight side of the linkage collar. That's going to move that linkage, bring that arm down, and that's going to give you the same preload when you hook up the valve shaft, the linkage to the valve shaft. It's going to be the same preload on the governor, as it will be with a stock height cylinder and the way we show you in the main installation video. So that's important. You want to have that preload on here and that washer arrangement set for if you're going to run the cut cylinder. The other thing I'll point out while I'm holding this in my hands is when you set it up that way for a cut cylinder, you need to add that 0.3 of a millimeter back in, but you do it in the spring shim stack. That way you're moving the linkage arm while maintaining the same overall spring preload. So the main thing we're showing you here is for the cut cylinders, go with the 0.8, bearing 0.8 on the weight side, and you're good to go. If when you take this apart, your bearings look like this, buy new bearings. They're like $7 a piece. Those bearings I showed you that were all come apart, the needles in those bearings measure 1.7 millimeters. A new OEM needles in there are 2.0 millimeters. So just with worn out bearings, that's 2 times 0.3 millimeter difference for a total of 0.6 millimeters. It has a huge effect on the preload of the spring. It's like equivalent to what people call the governor mod. The other thing I'll mention is that if you've got an older YZ250, this is from 99 to 01. They made these drive gears without the lightning holes in them, and the spring recess cut is a little bit deeper than on the newer bikes. So if you've got an older bike, you want to start off adding one additional 0.3 millimeter spring shim to the stack. That'll put you on a level playing field with the newer bikes. Here we've got the right side case. While yours is apart, check it. We've seen this one in particular where the linkage, where it comes out of the case, it has ears on it, and then those cast aluminum channels that it has so that it keeps it centered. But I'm not sure if you can see, but this one was migrating south and it was sawing right into that cast aluminum, that little flange there. And that was, that's a lot of friction if it's trying to migrate south for some reason. You can see right there, see on that, it was sawing right into it, and you could feel it. With our testing, we're into extremely smooth engines, and we could notice it. So we came up with a simple fix. If you take right from the hardware store some 11/32 round brass stock, it's the perfect diameter that slides right over that 8 millimeter linkage shaft. So we, cut a piece roughly 6.8 millimeters long, cleaned it up nice, and I'll show you how we put that together. So here it is with the little 6.8 millimeter long piece of brass tubing. So you have the linkage arm is taken off. You slide the linkage shaft back through the case, get it, that little brass tube over it, slide it all the way in, bolt down the linkage arm with the little Allen screws again, and then that's just going to float in there. It's going to ride on a coating of oil between it and the shaft, and there's play. Make it so you got play enough so it'll float around a little bit, but it can't possibly come out and even begin to interfere with those parts of the case that are intended to hold it centered. So it can't go in too far for the one, and it can't come out now. So nice and smooth, We've tested it. There's no interference at all. Yeah, and that just floats in there on a little coating of oil, and all is well. The one thing to note, if you notice, there's a spring-loaded, see that? That's the governor spring. That's how they are from the factory, and that's how it still is with these. So all bikes should have that little 0.5 millimeter of spring preload on that. If the case doesn't go on all the way, and I mean like if it's like that far off and it just won't go, don't screw it on. The gears aren't meshed. That's when you need to grab the kickstart, slide it on, and then just with a little bit of slight rotation and pushing in, pop, it'll go right on. So again, all these have preload on the governor. Hold down on the closing fork, lift a little to pull it off. Then again, line it up as though you were going to slide it on with your thumb. Raise the linkage, pop it on. At the risk of too much information, if you were to measure at this point on the arm, a standard YZ250, you would raise this arm about 1 millimeter of preload on the governor to be able to hook up the linkage. On an X model, you would have to raise this arm about 2 millimeters to be able to hook up the linkage. Now with this kit, it's going to be about 1.3 millimeters to hook up the linkage. So it should raise a little more preload than a standard YZ, not as much as an X model. So that should give you a rough frame of reference. So if you've got the bike all apart, you want to check out this secondary linkage. Okay, these pins that ride in the pulleys, if they're old and 1,000,000 miles on them, they will develop a flat spot, and it's not ideal. This one you can, yeah, I can't, right there. So you'll see if they're bad, you get a new linkage. The other thing to notice is you'll see on the forks where there's that worn spot. Both sides, these are stamped, and the one side really has a sharp burr. And those are wearing away and grinding on the secondary valve itself right in here, right on that opening edge. So while you've got it apart, grab a good file or your Dremel tool or something and relieve these edges of these forks. You'll see where they need to be relieved. And same on the secondary valves. You can just take the slight amount of that sharp edge right off of there. Then when you put it back together, it will be a lot less friction. Now here's something that's not required. It's just too much information. But for those that like to overdo everything, here you go. So you can take a piece of paper, cut a 75-degree angle out of one of the corners. Line up your power valves so they're over top of a Allen wrench or a jeweler's file or something, so the slots are straight in line with each other. Then you can lay this over, split the difference, and make a mark on the two valves, starting from the center of the valve, working down toward the point of your angle. So here's a white pen, here's a black marker. Okay, so you get the idea there. You just make a little jig, cut it out, line up the power valves, make a mark. Now you're going to take a Dremel or your choice of tool, and you're going to cut a little slot. It's 1.5 millimeters wide, which is a little wider than our wheel, so we had to work it a little bit. But you're going to you're going to make a cut from the center of the power valve down through and just into the start, or just past the bottom of that bevel. So it's just going to cut through on an angle from the center of the valve to just relieving it just down, just below that bottom of that bevel. 1.5 millimeters wide, roughly. When you've got that cut, take a jeweler's file or something and just knock the edges off of it all so that it all feels really smooth and there's not going to be any hot spots in it. While you got the file in your hand, you can relieve these edges on the factory slot there. They can be quite sharp and interfere with the linkage over time. So relieve all the edges of everything, cut that little, plow that little groove in there from the center of the valve down just below the beveled spot. When you're done making that groove, you can take a marker, mark the valve so when it's in, you can see which way it is going to be pointing downstream. So once these are cut, they're not going to be ambidextrous anymore. So you're going to want to position them so that that cut is pointing downstream and the combustion chamber has got the portion that was uncut. Now again, remember, when you put these in the cylinder, they're not ambidextrous anymore. You want to put that slot so that it's downstream, down the exhaust stream. So position it so it's down, going to point downstream when it's dropped down in. The magic marker mark will help you see that. You line that up for your linkage chamber. That black mark is pointing downstream. Pretty simple, but they can be mixed up now. So point them downstream. What this actually does is still being debated in-house. We just know with several bikes, it makes a difference. It's something to do with the casting. Each one is slightly different, but and some are arguing that there's other benefits as well. But anyway, if you want too much information, here you go.